Right, there are two different ways of finding the area of this triangle. One of them is using the formula which is in the front of your formula books, which says area is equal to half AB sine C. Okay, so I'm going to do this two different ways. Area is half AB sine C. So if I label the triangle, let's label it, doesn't really matter, I'm going to label that corner A, that corner B, that corner C. So that's little a, which is the length of this side, little b is the length of that side, little c is the length of that side. Okay, sine C, well that means this angle here. Now this is an equilateral triangle, and because it's an equilateral triangle, all of the angles are going to be 60 degrees. So if I just plug that into this formula, the area is going to be half times little a, which is 5, times little b, which is 5, times the sine of 60 degrees. Now I just need to type that into my calculator. Calculator will give me 10.8255, blah blah blah, and if I round that to three significant figures, I get 10.8. Okay, now I'm actually going to save that in the memory of my calculator. I'm going to call that little a, and I'm going to stick it in the memory of my calculator because I've got a feeling I'm going to use that later. Now another way of finding the area would have been to split the triangle vertically down this line of symmetry. Okay, and then I could have used the formula for the fact that the area is equal to half the base times the height. Now I've got to be careful here what I mean by the base and the height. That's going to be the base, so the base is just 5 centimeters, and this is going to be the height. Okay, I can't use one of these, remember, because the base and the height must be at right angles to each other. So that's the height, that's the base. Now we know the base is 5. The problem is, what's the height? And we can find the height using Pythagoras' theorem. That vertical line, the height, is actually a line of symmetry. So what we've actually got here is a right angle triangle, whoopsie, where the height of it we don't know. That's 5, and that's 2.5. So by Pythagoras then, we can say that h squared plus 2.5 squared is going to equal 5 squared. So that's just the same as h squared plus 6.25 is equal to 25. If I carry on then, subtract the 6.25 from both sides, h squared comes out as 18.75. It's a bit of a long way around this way. In other words, h comes out as 4.33 centimeters. Do not round that. Okay, the exact height is 4.33 and the rest. Okay, the area then is just going to be half times the base, which was 5, so half times 5 times 4.33, blah 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 blah, which you've kept on your calculator screen. If you work that out, it comes out again as 10.825, exactly the same answer as before, which again rounds to 10.8 square centimeters. Again, I will save that in my memory, okay, because I'm going to use it again later. Okay, here we have two circles which intersect, and they're helping you here by showing you that, again, here is that same equilateral triangle that we had before, and your job is to find the area of this shaded region. Now we already know the area of this triangle here, but we have to be a bit crafty here, because what we need to find is actually the area of these two bits, which are going to be exactly the same. And what I'm going to use here is the area of a sector. Okay, and you should know, basically, if you have the sector of a circle, so if that was the center of a whole circle, if this was a circle, and we know what the radius of that circle was, then we know that the area of this sector, and you need to learn this formula, is theta, so whatever this angle is, divided by 360, multiplied by the area of a full circle, which is going to be pi r squared. So in this case, I'm going to take this sector here. I'll just try and draw around the outside of it. So I'm going to find the area of this sector here. Okay, and this sector here, okay, you've got to imagine it is actually part of this circle. So we know that this angle here is 60 degrees because we've got our same equilateral triangle, and the radius of the circle is 5. So that purple area, if you like, I'll just draw it, can't really call it anything, but that sector area is going to be 60, so that's this theta here, divided by 360 times pi times the radius squared in this case, which is going to be 5 squared. Okay, and I can plug that into the calculator. Obviously I can simplify that. In fact, it just becomes pi and then the 6 and the 36 cancel to give me 1 and 6. So in fact it just becomes 25 pi divided by 6, which I can work out if I want to. It comes out as 13.089, so 13.0899. Okay, and I'm probably going to save that in my memory, and I'm going to call that B, just so I don't forget it. So I've got two numbers now sort of saved in my memory. Right, what I'm now going to do is work out the area of just this little bit here. Okay, just this little bit here, and you can see that this little bit here is actually going to be the area of this sector here, take away the area of the equilateral triangle. Now I've just worked out the area of the sector. So that shaded area, let me just draw a little picture of it if you like, that purpley shaded area that I've just shaded in like that, that is going to be the area of this sector. So that's my 13.089 that I've saved in my memory. Take away the area of the equilateral triangle, and the area of the equilateral triangle was that 10 point, but I mustn't use 10.8. The exact area of the equilateral triangle was 10.825 that I've saved in the memory of my calculator. So 10.825. If you don't know how to use your memory, learn. Okay, and I'm going to subtract one from the other, and that's going to give me 2.6465, 2.6465, blah, 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 blah. And again, I'm going to save that in my memory. That is the exact area of this little bit here. Now I can see that the whole shaded area, so the area that I want, okay, so if you like, my answer is going to be the area of my equilateral triangle, well, that was 10.825, conveniently saved in my memory as A, plus 2 lots of this one here. So in other words, 2 lots of the 2.6465, etc. Again, saved it in my memory as C. So all I've actually got to type into my calculator is A plus 2C. And if I work that out, it comes out as 15.35, so 15.3546 and the rest of it. And if I round it to the required 3 significant figures, it usually is, I get 15.4 centimeters squared.